In this lecture, we will talk about examples. The first one is draw the graph of function y equals cotangent 7x. Here is cotangent 7x, and the graph is actually based on graph y equals cotangent x. Remember, cotangent x is a decreasing function. It goes lower from higher place, goes to a lower place. Okay, and the cotangent x has the period pi. All right. So when x equals 0 and pi, cotangent x are not defined. Undefined. Okay, when x equals pi over 2, cotangent x is 0, so the x-intercept is pi over 2, 0. Okay, for cotangent. And when x equals pi over 4, you have a cotangent has value 1. So pi over 4, 1 is on the graph for cotangent. And when x equals 3 pi over 4, you have a cotangent x is negative 1, right down here. So x is negative 3 pi over 4, pi y cotangent 3 pi over 4 is negative 1. So you have a values right here. You may choose, more values in between pi over 4 and 2 pi over 2. Yeah, you may choose more values here. You may have more points. Okay, but here for the simplification, we may just choose 3 values. Okay, to remind everyone, cotangent x goes in this way. Now here is cotangent 7x. Since the period is pi and the coefficient here is 7, so the period will be pi divided by 7. Okay, this is different from sine and cosine. Cosine and sine have period 2 pi, so it is always the coefficient of x as a denominator, but there was 2 pi. Here is pi, because cotangent, tangent have a period pi. Okay? And here is why we use coefficient as a denominator, because when x equals these 3 different values, when x equals pi over 28, and 7 times x is pi over 4. Okay? When x equals pi over 14, 7 times pi over 14 is pi over 2. Again, when x equals 3 pi over 28, 7 times 3 pi over 28 is 3 pi over 4. So when 7x equals those 3 different values, is basically when the quantity here is those 3 different values. And then we will have a cotangent pi over 4 is 1. As you see, cotangent pi over 4 is 1. And then cotangent pi over 2, because 7x is pi over 2. Okay, so cotangent pi over 2 is 0. Again, cotangent pi over 2 is 0. And cotangent 7x again is 3 pi over 4. So cotangent 3 pi over 4 is negative 1. Cotangent 3 pi over 4 is negative 1. So basically, I want to say is that those 2 rows are the same. The only difference is the initial values for x values are different. X values are different. So, and then, you know, when x equals pi over 7, then 7 times pi over 7 is pi. And we know cotangent pi is now defined. Okay? That's why we say here pi over 7 is the asymptote. Alright? So is the case for y-axis. Y is also the asymptote. Remember, this curve can approach this dotted line as close as possible, but it never touches this one, asymptote. So is the case for this curve. This curve never touches y-axis, but can be very close to that. If you don't remember the graph for cotangent, basically you do, you can use your calculator. But right down here is that I want to complete this example is that pi over 28 is right here. Okay, and then 1 is here. Okay, so you may mark here is 1, here is negative 1. Alright, when x is pi over 14, you have a 0, so this place is pi over 14, 0. 3 pi over 28, 3 pi over 28 is when x equals the value here, and then you have negative 1 for that. So basically shapes are similar, but only x scales are different. You see, those three values, 1, 2, 3, 1, 2, 3. X values are different, okay? Y values are the same. That's why we said actually the period is changed. Now, again, we may go back is that if you don't remember this picture for cotangent, you may go back, turn on the calculator. Remember, cotangent is the reciprocal of tangent, so you may do 1 divided by tangent, and then x. There is no cotangent on TI 83. They assume you know the relationship between cotangent and tangent. So when you draw the graph, so you see asymptotes, it looks like this line already touched the vertical asymptote, but that's not the case. That's because of the pixels on the monitor. Okay, the real case is that those lines can never touch the dotted line. This is what we need to, to be clear when we use the calculator. Remember, you can always use the assistance of the calculator, but sometimes they give you something, not exactly right. Now, let's draw the graph of the second example. Y equals cotangent 9x minus pi. Remember, cotangent has the period pi. So then this function minus pi, we basically don't need that. Okay? Because you subtract pi is you subtract one period. Okay? So then the function can be written as cotangent 9x minus pi is just cotangent 9x. And then the period will be the period of cotangent pi divided by the coefficient 9 here. Okay? Then follow the pattern above. You may do the things right here similar. You see, when x equals something, then you will have a 9x equals something, and then you then have a cotang 9x. Okay, so what's the middle value here? The middle value, you can see down here was pi over 14, and then down here what we should put. You know, basically here was pi over 7 multiplied by 2. So then how about here is 9 multiplied by 2. It's basically right here. Okay, from 0 to pi over 9, that's one period. The period is pi over 9. Okay, pi over 9. And then the middle point will be pi over 9 divided by 2, or pi over 18, right here. And then between those two, 0 and pi over 18, that's the halfway. So it's pi over 36. And from 0 to pi over 36 is this long. This will double the pi over 6. From here to here will be 3 times as much as pi over 36. So basically you can write 3 pi over 36. Okay, now when x equals pi over 36, 9x times pi over 36, then we get is pi over 4. Huh? When x equals pi over 18 times 9, 9x is pi over 2. And then when x equals 3 pi over 36 multiplied by 9, so you then have a pi over 3 times 4. So when the quantity 9x equals those 3 different values, when cotang pi over 4 is what? Is 1. Cotang pi over 2 is 0. And cotang 3 pi over 4 is negative 1. Again, I want to emphasize is those two rows are the same. Okay? So only 3 values here are different. Again, you may insert as many values between those two or between those two as you wanted. But you know, again, we want to make our case easier, so we just choose those 3 different values. And then, you know, here pi over 36, 1, pi over 36, 1, you may put right here, this point, huh? And here is 1. And then pi over 18, 0, pi over 18, 0 is the x-intercept. And then 3 pi over 36, 1, negative 1, so you put right here. Okay, so here is negative 1, huh? Here is negative side. So then pi over 36, here is negative. Huh? So you may mark this point or this point yourself. Okay? Remember here I put is 3 pi over 36. Here is negative 3 pi over 36, which can be reduced to pi over 12. Okay? And this is your job. You can reduce that yourself. Okay? Here are the 2 examples. 1, 2. And here, this one is a little bit tricky. It's minus the period. So you don't have to use subtract pi. Huh? Remember the basic pictures. Okay. Please review this lecture. I'll see you next time.